So, ladies and gentlemen, welcome to this video. Here we are going to check out how you can have Theo work together with your favorite AI agent in order to generate design methodologies, complete automated design methods. So the task will be to size an MLE plant, a simple anoxic and aerobic tank combination, by actually sweeping through various sizes of the aerated tank, sweeping through the internal recycle flow, the anoxic tank volume, and find an optimum. This is, of course, a simplified approach here. We are just demonstrating how this can work together with Theo and an LLM model. And what we ask our model to do is actually build the whole plant automatically, come up with some code which can do the parameter sweeps completely autonomously, and then, of course, show us the sizing results and eventually show us the code. This is not the first time I see this, but this is still my favorite part, when the LLM starts throwing various process units to the drawing board, connecting them. And well, initially this looks like a small child's drawing. It will be somewhat better, still not perfect, but probably you get the idea, like how an LLM can put together this plant schematics for you autonomously. As the LLM starts working on the task, actually the lazy user wants to have some additional outputs as well. But apparently I was just lazy to implement additional charts, so we are going to add those charts manually later on. It will not affect the purpose of this video, and something unexpected happens as the engine gets crashed. Well, this is not the expected behavior, but don't panic. Theo can actually pretty well recover from these things as well. Voila! The show just goes on. So we are going to need some charts, some output data representation, and we just drag and drop it from the configuration dialog to the chart for various variables. Ammonia and nitrate are probably the most important ones. And let's just make it a bit larger so that we can see what's going on. Because technically, what's going on here is that the LLM started sizing our treatment plant. If you remember, the setup was organized in a way that first we should actually sweep the aerobic reactor volume. And now this is happening. Let me show by actually checking out the values as numbers for both the ammonia, the nitrate, once again. Yep. So in addition to the nitrogen forms, we are going to need the reactor volume as well. Drag and drop again. As well as the, what's that? The recycle volumetric flow rate. Same drag and drop thing. And the system just continues the sweeping actions. So let's see how it works. So apparently we have enough results to check out some summary charts. So this is actually pretty similar what you would draw by hand if you did all these simulations one by one on a traditional simulation environment. And here you get it basically for free. The system gives us a pretty detailed summary, and since it was so easy, let's just see if we can extend the original assignment of sizing a simple MLE plant to sizing an MLE plant with some post-anoxic denitrification as well. This will, of course, take a slightly different plant as well, so take a look at the focused area now, because our LLM will actually restructure the treatment plant. So by this time the LLM did some code modifications for us, and now we are doing a post-denitrification tank sizing sweep. So with the new plant we need some new outputs as well, and this is a wonderful opportunity to show you how you can add new columns to a table. Well, since we have two charts right next to each other, it would be just nice to set all the y-axis to the same minimum maximum configuration. So instead of the automatic range, let's just use a fixed 0 to 20 zone everywhere, which will mean that we can directly compare the two charts. As we have seen, the system performed the sizing, but what's more important, there is a code that also has been born during this session. And this code is probably the more important product, so let's just check out how it looks like. So the code is, well, of course, a part of the sizing approach that the system has developed. It is important to note that this is using the Python API of Theo. This example shows how all these various components shipped with Theo can nicely work together to generate something in a few minutes that normally you would work on for weeks.